And this section's in the multiplication properties of exponents. Property of exponents. And I just said we're going to learn how to multiply polynomials, but before we do that, we need to know how to handle the exponents when we multiply them. So there's three basic rules we're going to live by, and I'll give you the rules and I'll break it down in a second. But first of all, let me just give them to you. So the first rule we're going to talk about is the product property of exponents. The product property of exponents. And that rule says if we have two numbers with the same base, so here we have the base being x in both cases, the power in the first one being a, the power in the second one being b, I'm going to keep the same base, which is going to be x, and I'm going to add up my exponents. So that's a plus b. Okay, so let me give you an example of that. An example of that is if I have, for example, 5 cubed times 5 squared. Well, here I have the same base, being 5, and different exponents, 1 cubed, 1 squared. So I'm just going to add up my exponents and keep the same base. So my answer is going to be 5 to the 5th power. Okay, that's the first rule. The second rule is called the power property of exponents. And the power property of exponents says if I have the same base, or actually one base, to some power, and then all that to another power, my answer is going to be the original base, and I'm going to multiply both powers together. Let me give you an example of that. An example of that, say that I have y squared to the 3rd power. Well, the rule says if I have a base to some power, then to another power, I'm just going to multiply the exponents together. So that's going to give me y to the 6th power. And there's one more rule we're going to learn, which is the power of a product property. And the power of product says if we have a product of two numbers, say x and y, and then I take that product to some power, a, then my answer is that I'm going to give the power of a to both the x and the y product. Oops, y to the a. It should be an a right there. So let me give you an example of that. Say I have 2x and I'm cubing 2x. Well, there's a product of 2 and x to some power, so I'm just going to take the 2 to the 3rd power and the x to the 3rd power. And I can simplify this and it would just give me 8x cubed. Okay, so these are all the basic rules we're going to talk about. So keep this page kind of handy. We're going to talk, but we're going to go refer back to them. Let me explain each of them individually. So let me start with the first one, which is the product property of exponents. And let me just rewrite it. It says x to the a times x to the b equals x to the a plus b.
Wait, I have a question. How does that equal 8x?
2 cubed is 8. Do you get how we get to this step?
Yeah.
Okay. 2 cubed is 8, and x cubed is just x cubed. 2 cubed is 2 times 2 times 2, which is 8.
Right.
Was that it? Okay. So let's talk about where these rules come from. So say we have x to the a times x to the b. We know that's x to the a plus b. Well, let's talk about where that comes from. Let me give you an example. And let's take the example x squared times x cubed. Well, if I don't know the rules, if I don't know how to take care of this, I do know how to do some things. I do know how to expand. So if I were to expand x squared, that's the same thing as x times x, right? And if I were to expand x cubed, that would be the same thing as x times x times x. Well, I just have a bunch of x's. I know how to write that in exponential notation. In exponential notation, I'm just going to write x to what power? 5, just because I have 5 x's. So all that means is I'm multiplying x times itself 5 times. So the shortcut here is you're always going to have the expansion of the first base and the second base, and together you're just going to add up how many times you see them. So that's why we use the rule a plus b, just to save us some time. But you can always expand it yourself and you'll get to the right answer. Okay. Let's keep it easy. Say I have z to the 5th times z to the 6th. What do you think that's going to give me? Z to the 11th. Good. Okay. Let's take it a step up. Let's say I have, let's call this example A, B, C. Let's say I have 8y to the 5th times 4y to the 9th. Here I run into a problem because my bases are now, I have different bases. I have numerical bases and I have exponential bases, or variable bases. So what do I do?
Do you multiply the base and then just add the exponents?
Multiply, I think we're on the right track. What were you going to say, Belinda?
Well, that would be 32y.
Okay, and I think you're both trying to say the same thing, which is basically multiply my numbers together and then multiply my variables together. So I can do that because the order of multiplication doesn't matter. So I can do the 8 times 4 part first, and then the y to the 5th times y to the 9th. So 8 times 4 is 32. And to do y to the 5th to y to the 9, I use the rule that I just learned up here. X to the a times x to the b means that I just add up the exponents. So what does that give me?
14.
So my answer is 32y to the 14th. Let's try another one. Say I have negative 4 r to the 6 s squared times negative 3 r squared s to the 5th. It's a little bit more complicated, but it's really the same thing. What do I do here, do you think? Same thing. What do we mean by the same thing? Yeah.
Start on the left side, do 4 times 5.
Do what?
Oh, no, that's nice. You're just going to have to multiply the 1 negative 4 and the negative 3.
Right, multiply my numbers together.
And then do the exponent, which is 6 and 2.
Do the r's first, right?
Yeah.
So basically separate my bases so that I can take care of it, and then do the s's. So you get s squared times s to the 5th. Okay, now let's just simplify this. So negative 4 times negative 3. Positive 12. Yeah. R to the 6 times r squared. Right, because I just add up the exponents. And s squared to s times s to the 5th. S to the 7th. And this would be my final answer right there. Okay. Note that this is not the same thing as 12rs to the 15, right? Because here r is to the 8th, s is to the 7th, I cannot add up the exponents because of different bases. In the case when they are the same base, like with the z's, I can just add up the exponents. These are not the same base, so I can't do this. So don't do this. Okay, let's do one more of these. Let's do 11y to the 5th times 3y squared times y. Go ahead and do that one. Before you do it though, what is the exponent on this y? 1. So although you don't see an exponent there, keep in mind that it's a 1.
Under 4D, when you have the answer right there, right, 12R8, do you have to put the multiplication symbol in between that and the S7?
No, it's understood that if there's no symbol there, it's a multiplication. So notice sometimes I do, like here. Sometimes I don't, like in between. I don't really need to.
I was just wondering what purposes will they,
They'll take it if you don't put a multiplication. They should.
if they don't, they should take it?
They should take it. If they don't, I don't know why they don't, but they should. So what do we get out of E?
34.
To the 8th, because there's a 5, a 2, and a 1. So it's 8. Right, y to the first power. Did I put 7? This is an 8. It may look like a 7, but it's an 8. Okay, good. Let's move on. So we just did... So I just went and explained in great detail where the product property of exponents goes. So why do I add up the exponents?
Does the rule?
It's the rule, yes. But I can come up with the rule.
Because the exponents don't really, they're all the same. Your x is your base, which is multiplying, where your exponents, they're always going to stay the same amount. You're just grouping them together so you have the total.
Okay, good. So this is the same thing as saying, okay, if I have I have a whole bunch of x's. I can group the first group of x's, that's my first x to the a. I can group the second group of x's, x to the b. But in reality, I just have two groups of x's, and I can just add up all their powers. That's what I did over here. Remember I said we can group x squared is x times x cubed is x times x times x. So I really just have 2x's plus 3x's, it's 5x's. So that's why that shortcut works. Let's talk about the second one. Why does that second shortcut work? So the second shortcut said if we have x to the a to the b power, my answer is going to be x to the a times b. Let's talk about why that works. So say I have an example where I have x squared cubed. How do I expand x squared cubed? Let's start with the inside. How do I expand the x squared? X times x. Then if I'm cubing x times x, what does that mean? There's 3 of those x times x's. Okay? So how many x's do I have altogether? 6 x's. So I have 2 x's for each part of the inside times 3 times that I have the 2 x's. That's how I get the 6 x's. So this is why this rule works. This rule works because I'm saying I have the number on the inside a times, and then that's being multiplied b times, so that's why it's a times b times. Okay? So let's try one. Let's say I have an easy one. X to the 4th cubed. What would that give me? X to the 12th. Because I'm going to have 4 x's and then 3 groups of 4 x's, so it's going to be a total of 12 x's. Let's say I have z to the 4th to the 5th times z to the 3rd to the 7th. So I may not know how to do them all together, but I can do them separately. I can do this one separately. What does that give me?
20.
Z to the 20th. And I can do this one separately. What does that give me?
41.
Yeah. And what is the operation between these two? Multiplication. Right. So which rule do you use here? Do I keep using this rule? No, I go back to the first rule, right? Because same base, different exponents, so just add them up. What do I get out of that?
41.
Z to the 41. That's it. So again, why does this rule work? Yeah, I have the group inside, and I'm multiplying times the number of times I have that group. Okay, let's break down the third rule. So now we're done with the second rule. We're up to the third rule, which is the power of a product. So the power of a product says, let's make sure I write it the same way. If I have two bases, or a product of two bases like x and y, to some power a, then that means that it's the same thing as the first factor to the a power, the second factor to the a power. So let's say I have an example where I have xy to the third power. Okay, well, I don't have anything to expand inside, but how do I expand the whole thing? X times y times x times y times x times y. You're using the rule, and that's okay, but we're trying to make our way to the rule. We're trying to figure out how the rule came about.
Break it down into x to the third and y to the third.
Right, so what I'm saying is once I have x, y 3 times, well, remember the order of multiplication doesn't matter. So I can write it as x times x times x, y times y times y. I'm just regrouping things. And then this ends up being x 3 times and y 3 times. And this is going to happen anytime you have something like this. Anytime you have numbers being multiplied together and then all that to some power, you're going to have each one of the numbers to the same power. Okay, now let's go ahead and use the rule. So now that we know where the rule came from, let's use a shortcut. How do I do this? 3b to the fourth power. 3 to the fourth, b to the fourth. And let me go ahead and simplify. What's 3 to the fourth? So break it down to 3 squared times 3 squared. 9 times 9, which is 81. So it's 81b to the fourth.
So you have to simplify, you can't just give it like 3 or 4.
Right, you have to simplify.
Wouldn't that just be 3b to the fourth power? I mean, I don't understand why you would break the 3 and the b.
Okay.
You know what I'm saying?
3b, well, let's expand it and watch it. When that fourth means that anything inside the parentheses is to the fourth power, right? So if we expand this, it's 3b times 3b times 3b times 3b. So I have 4 3's and 4 b's.
Which would turn out to 81b to the fourth power.
Yeah. So I understand what you're saying. It's a number. It looks different because it's a coefficient, not a variable. But that doesn't matter. Because remember, all variables are numbers. We just don't know what number they are. So even if it's a number, you give it the fourth power. Alright, let's try one more. Let's try 4x squared y to the 6 to the third power. How do I do this?
What power is it?
6. And this is 3 on the outside. So what does the rule say to do?
2 3 times.
Well, the rule says if I have a product of numbers like x times y, give the a power to every number that I'm multiplying. So it's going to be the first number, 4 to the third power, the second number, x squared to the third power, and the third number, y to the 6 to the third power. Everyone with me here? All I did was I followed the rule to give the power to everything inside. Okay? Now let me evaluate this. 4 cubed, what's that, 64? X squared cubed, how do I take care of that? Which rule is that?
Second.
The second rule, which means I multiply the powers together.
So x is
Yes. And what about this one right here?
same.
And then that would be it right there. Okay. 2x squared y to the fourth times 3x to the 6 y to the 9th squared. Alright, I have a big combination of multiple rules here. So let me do them. Which y? The first one or the second one?
Now,
This one?
yeah, what's your small one now?
4th.
Oh, sorry.
It's okay. Okay, so my last rule, the one I just learned, this rule number 3 up here, tells me that I need to take that 4th power on the outside and give it to every number I'm multiplying inside. So it needs to be 2 to the 4th times x squared to the 4th times y to the 4th to the 4th. So I did that with this 4th right here. I'm going to do the same thing with this squared to everything inside its factors. So it's going to be 3 squared times x to the 6th squared times y to the 9th squared. Everyone with me here? Okay, now that I'm here, I can start grouping the numbers together, the variables together, the x's together, and the y's together. So 2 to the 4th will give me 16. 3 squared will give me 9. I can take care of that later. Then the x squared to the 4th. What's x squared to the 4th?
X to the 8th.
I use the second rule. It gives me x to the 8th. Oops, I shouldn't have closed the parentheses, but whatever. And then x squared, x to the 6th squared, what does that give me?
X to the 12th.
Yep. Then I can do the y's. Y to the 4th to the 4th. And y to the 16th. And the y's to the 9th squared. Y to the 18th. And finally I can finish this up. 16 times 9. Gives me 144. X to the 8th times x to the 12th.
Isn't that when you add it?
Yeah, this is the first rule. So this is a good problem because it combines all the rules. I add them together. What do I get out of that?
X to the 12th.
And then the y's, what do I do there?
Let's get it, add it together.
Add them together. And I get y to the 24th. So my final answer is 144, x to the 20th, y to the 24th.
Yeah, what happened? 6
It'll be 34. All right. Okay. Yeah. Let me make one up. So say we have 3x squared y cubed to the 4th power times 4x to the 8th y to the 7th to the 2nd power. So this is the same similar problem. Okay, so I'm going to start by one of the rules, using one of the rules. If I can't do the first rule yet because I have no two x's I can combine, because this x is inside this 4th power and this x is inside the square power, so I can't do that yet. I can't use the second rule because I don't have any single factors to some powers. I need to start with the third rule. And the order of operations tells you need to start with the third rule anyway, exponents. So let me do that. The third rule tells me I have to take this 4th power and apply it to everything inside. So it becomes 3 to the 4th, x squared to the 4th, and y cubed to the 4th. So I've only done the left side. And in fact, let me keep going with the left side just so that I don't work on two sides at once. What's 3 to the 4th? 81. What's x squared to the 4th? X to the 8th. And then y cubed to the 4th is y to the 12th. So I just did the left side. Now let me work on the right side. So the same thing. The third rule tells me I have to apply the square to everything inside. So that's going to be times 4 squared times x to the 8th squared times y to the 7th squared. Okay, now I'm simplifying this. 4 squared is 16. X to the 8th squared is going to be x to the 16th. Oops. Should be a 6. And y to the 7th squared should be y to the 14th. Once I'm at this point, I'm done with rules 3 and 2, and I just need to work on rule 1, which is combine all the like bases. So 81 times 16, I'm going to multiply, and that's going to give me some number. I don't know. I can do it on the side. So that gives me 1496. X to the 8th and x to the 16th, I add up the exponents, keep the same base. It's going to give me x to the... And then the y's, I'm going to do the same thing. That's going to give me y to the 26. That would be it right there.
So no number is with a variable, like you know how right here you have 2x and you have 3y. It's not like that.
No. In that case, we're adding and terms. We had different terms that we're adding together. In this case, we're multiplying, so everything's kind of all together. And the numbers are just as valuable as the variable are. So they get the powers too. Okay, we're good with these rules. So we're going to use these rules now to multiply volume.